Hello, my name's Alistair. So let's spell that out there. So my name's Alistair, and I'm here to help do with mathematics on this course. So originally my first couple of degrees were in physics, and then my later degree was in PhD, was in engineering. So when they basically what they wanted was somebody to help out with the mathematics that's not a mathematician. So basically, I used the physics to figure out how the the universe worked. That's why you do physics, because you want to find out how everything works. And then I did engineering because I actually wanted to build stuff. And building stuff is what engineers do. So what we're going to be using is we're going to be using mathematics. And the big question is, the first question when we're doing math and science is why? Why do we do mathematics? And the answer is because to date, it is the best method that we have of modeling reality. And one of the reasons for modeling reality is that it also allows us to make predictions about the future. So it allows us to make predictions about the future behavior of, I don't know, is that bridge going to be standing in 10 years' time? Will that transistor be able to handle the voltages and currents that we're actually throwing at things? It's Yogi Berra, the great Yogi Berra, who, I don't know if you know him, was a baseball player, or was a baseball player. He said it is very hard to make predictions, especially about the future. So basically, yeah, what I've been trying to use mathematics for was originally for car suspension systems, and controlling car suspension systems and modeling how magnets work. And later on in my engineering degree, now I'm working on how to actually build rockets and how rockets actually behave when you do things. So you're going to be engineers. So basically, what's the difference between engineering, let's try that again. What's the difference between engineering and the trades? And nothing wrong with the trades. Trades is a very good way to earn money. And if you find a really good tradesperson, hang on to them for dear life. Because remember, the people doing the trades turn your vision into reality. They're the people actually turn stuff on lathes and make stuff with. But what's the difference between these two? And the answer is very simple: mathematics. So, and even in the trades nowadays, you're expected to do a lot of mathematics. But the difference, one of the big things is, as I said, mathematics. And one of the things is engineers. So engineers do things faster than ordinary people, cheaper because we use less materials, safer because we can predict things using mathematics, and we also can do it legally so that we obey all the laws of the land. So that's one of the things, the differences. And this is why you're doing stuff. This is one of the things that distinguishes engineers from ordinary people. And we do things faster, cheaper, safer, and legally. And I mean, some of my favorite examples of this, of course, is people like von Braun. Might not have been a great human being, but he was given permission back in the day, but the Russians stuck up Sputnik and the Americans said, oops, we've got to have something up now. They tried Vanguard had blown up a couple of times. So they basically told von Braun, make a rocket, and the time between they told him to make a rocket, we had it flying was 84 days. And that's because he might not be a great human being, but he was a great engineer. So where are we as engineers? Where's the major areas that we're going to use mathematics? And there's two major areas that we're using mathematics that we're going to teach: modeling and control. Those are the two major areas that we're going to use it. Modelling is making a model of the universe or model of whatever we're trying to do, behaviours of materials or stresses and strains, and how structures are going to withstand that, or how electron flows. So modelling allows us to predict the future, and control often will take our model and our predictions and then allow us to control our environment. Whether this be in a wastewater system where we're figuring out how much water's going through there and then which gates to open, or sewage systems or car suspension systems. So those are going to be our two major areas, and it doesn't matter whether you're doing mechanical engineering, electrical, software, CAVE, mechatronics, civil, environmental, materials. At some point, you're going to be doing modelling, and at least modelling and hopefully control is this. So, as far as we're concerned, mathematics was invented. About a third of mathematics was invented for STEM. A third was invented for tax purposes, and a third invented because, hey, mathematics is, we've got to have a look at all of mathematics. So for us as engineers, mathematics is a skill, and that means it is something that we do. We actually go do math. The math we're doing here is the math that we've agreed as engineers, the Engineering Society. This is the math we've decided all engineers should know, so they can communicate with other engineers, so they can express what they're doing. The easiest way for us to express what we're doing and do it is using mathematics. So mathematics is a skill, and for mathematics is for use, for doing. We use mathematics in engineering all the time. A lot of the time nowadays this is computer assisted, and often the drudgery math nowadays is done by computers, but the math, under everything we do in engineering, it's underlined by mathematics. So the question is, how do we learn mathematics? Or how do we pass this course? How do we pass this course? And there's a few things that we can do. Basically, do all of the work. And what I mean by that is do all of the workshops, do all of the assignments, do all of the tests, do the exam if we have one. But basically, you should do all of the work, because the more that you practice, the better you get, especially if you've got people keeping an eye on you. Like when you learn to drive a car, for example, or ride a bike, if you learn how to drive a car, you can read all the books you like on learning how to drive a car. But at some point, you've got to actually get in the car, grab the steering wheel, put it in gear, and take off, and try and avoid crashing into a power pole. So ask for help if you need it. You have available about 10 math help sessions or 9 math help sessions a week. The mathematics department puts on a mathematics help session every day at 1 p.m. in G333. That's for general math. Also downstairs, and I can't remember, teaching resources, whatever, they put on specialist engineering mathematics workshops and help workshops every day. They put on about 4 of those a day. Hopefully we've linked them onto the Moodle site. So if you need help, ask for help. So the first thing that we're going to be doing in workshop number 1 is we're going to get you to do a test. And this test is a diagnostic test. What it means is basically the first test is to let me know what areas you're strong in, what areas you're weak in, and what areas we should teach you how to. So hopefully by now you've either done this or you have found this test. So if you're doing this test online, I'll actually put a copy of the test on Moodle. Tell me what the answers are, A, B, C, D, E, and email the answers to me. So do the test, figure out the 10 answers, and then email the answers to me. And okay, so I'll see you in workshop number 2. So good luck on that, and yeah. So just make sure you do the test and do all of the work.